Good day, everyone. We are Group 7 and we'll be presenting to you the testing of concrete beams and cylinder. Before we start the video, we'll be having a brief introduction of what this is all about. This practice provides standardized requirements for making, curing, protecting, and transporting concrete test specimens under field conditions. This experiment's goal is to design and construct a concrete beam sample in accordance with the practice ASTM C31. In this video also, we'll be focusing on testing the compressive and flexural strength of the beam and cylinder samples being made by the previous groups. So, just to clarify, the making of the beam sample will not be a part of this video. However, we'll be focusing more on the flexural and compressive strength of the beam and cylinder samples. The materials used are the compression and flexural testing machine and the metal ruler. So the reference standard for this experiment is the ASTM C31, or also known as a standard practice for making and curing concrete test specimens in the field. In addition, we also have an additional databases, which is the DPWH Blue Book. And now we will be proceeding to the procedures for this experiment. First, using the metal ruler, measure the length, width, and height of the beam sample. For the cylinder, measure the diameter and also the height before putting it into the compression and flexural testing machine. Second, place the beam sample into the testing machine. Make sure that the beam sample is properly placed to ensure proper testing for the flexural strength. Third, after placing the beam properly, place then the loading point plate to start the test. Fourth, stop the machine once the beam starts breaking. Place the base plate of the cylinder on both ends. Make sure that it is properly centered to ensure the surface area being target on the machine. Start the testing machine and wait for the cylinder to reach its maximum compression strength.
And now, we will be proceeding to the results and discussion. In this experiment, again, we have used the ASTM C31 standard, but we also have an additional basis, which is the DPWH Blue Book. According to the DPWH Blue Book 311.2.11, entitled Proportioning, Consistency, and Strength of Concrete, it has been specified that the required flexural strength is 3.8 megapascal or 550 psi. On the other hand, the required compressive strength along with Class B in Table 405.2, composition and strength of concrete for use in structure is 16.5 Newton meter squared or 2400 psi.
Now let us discuss the results of compressive strength for the cylinder samples done by the previous groups. We have here the first batch conducted last June 23 and was tested last July 18, which had 25 days for curing. The formula used for this is force over cross-sectional area of the cylinder. For sample 1, we have here a diameter of 0.55 meters and a radius of 0.775 meters, and a force is equal to 0.4487 meganewton. The units were converted to M and meganewton to be able to achieve the final unit of the compressive strength. So, compressive strength is equal to 0.4487 meganewton over pi times 0.775 meters squared, which is equal to 23.78 MPa or 3449 psi. For sample 2, we have here which is equal to 21.05 MPa or 3053.04 psi.
Next is the second batch conducted last June 27 and was tested last July 18, which had 21 days of curing. For their sample 1, we have a diameter of 0.156 meters, radius of 0.078 meters, and a force of 0.5817 meganewton. So compressive strength is equal to 0.5817 meganewton over pi times 0.078 meters squared. For sample 2, we have here their diameter of 0.156 meters, radius of 0.078 meters, and a force of 0.5441 meganewton. The compressive strength is 0.5441 meganewton over pi times 0.078 meters squared, which is equal to 28.47 megapascal or 4129.22 psi.
After the compressive strength, we will now proceed to the flexural strength of the beam samples. We have here the first batch conducted last June 23 and was tested last July 18, which had 25 days for curing. The formula used for this is FL over BD squared, where F is force, B is width of beam, L is length, and D is thickness. For sample 1, we have here their dimensions of 0.535 meters by 0.155 meters by 0.155 meters, and a force value of 0.0352 meganewton. Using the formula that was given earlier, we will now input the data and information that we have collected from our experiment. For the first sample, it's 0.0352 meganewton times 0.535 meters over 0.155 meter times 0.155 meter squared. So the flexural strength for the sample 1 is 5.06 megapascal or 733.89 psi. While for the sample 2, we also have here their dimensions of 0.535 meters by 0.154 meters by 0.154 meter, and the force value of 0.0267 meganewton. So the flexural strength for sample 2 is 3.91 megapascal or 567.1 psi.
For the second batch, we also have two samples conducted last June 27 and was tested last July 18, which had 21 days for curing. For sample 1, we have here their dimensions of 0.535 meters by 0.155 meters by 0.155 meters, and their force is 0.0308 meganewton. Again, the units were converted to meters and meganewton to be able to achieve the final unit for the flexural strength. Here we have the calculation or the solution for the flexural strength for sample 1 equal to 4.42 MPa or 641.07 psi. For sample 2, we have their dimensions of 0.537 meters by 0.154 meters by 0.154 meters again, and their force is 0.0361 meganewton, and it is equal to 5.31 MPa or 770.15 psi. So, to conclude this experiment or video presentation, we have here two tables prepared so that we'll be able to compare the required compressive strength and flexural strength easier to the data. So first we have here table 1, which is compressive strength determination of cylinder samples. So we have here the first two samples conducted on June 23, which spent 25 days for curing. We have 23.78 for the first sample and 21.05 for the second sample. For the next batch, we have the June 27, which is 21 days that was spent for curing. We have 30.43 and 28.47. So the required compressive strength for this one, according to the Class B of the DPWH Blue Book, is 16.5 MPa or 2,400 psi. And as you can see, all samples have passed the compressive strength for this experiment. Next is Table 2 for flexural strength determination of beam samples. So the first batch, we have 2 samples, also conducted in June 23, spent 25 days for curing. We have 5.06 and 3.91. For the second batch, which was conducted on June 27, that spent 21 days for curing, we have 4.42 and 5.31 megapascals. So the required flexural strength is 3.8 megapascals or 550 psi. And again, as you can see, all the data or all the samples for the beam has passed the required flexural strength. With this, we can conclude that all the samples have reached its flexural and compressive strength before 28 days.